Last weekend I did kind of an extended live stream of making a Roon endpoint from a Raspberry Pi, but I'd like to run through that process a little bit more quickly here just to give you an idea of what this process looks like. The project was to take a Raspberry Pi 3A Plus, which is a $25 kind of small board computer. I'll show you what that looks like in just a minute. To take this $25 computer, flash a microSD card with the appropriate software, boot it up, and make it into a usable Roon endpoint. In this case, the Roon would talk to this device over Wi-Fi, so over a network connection, a Wi-Fi network connection, and it will stream to an attached USB DAC. There's some advantages to doing this over using a general purpose computer. Chiefly among those is just that the Raspberry Pi is a much lower power, lower noise device. But obviously it's much less cost as well. So it's a great way to kind of get into using Roon's distributed architecture and getting used to the idea of having separate endpoints throughout your house, endpoints that are separate from your core and that are very, very low noise. So here's what the Raspberry Pi 3A Plus looks like. You can see it's very small. It's maybe a bit larger than a credit card or so. It has a single USB port on one side that we can connect a DAC to. It's a USB, it's not USB 3, it's just USB 2, but that's all we need for audio. That's good for 32-bit 768 kilohertz PCM. It's good for a DSD 512. It's good for all kinds of crazy rates. So we don't really need anything more than that. We have an HDMI port that we can use for debugging, but it's generally not used. As far as I know, Linux doesn't support multi-channel streaming, so we tend not to use that for audio. It's just for troubleshooting. Power inlets here. On the board itself, you can see this little chip that's, maybe you can see, that has a kind of raspberry engraved on it. That's the Wi-Fi chipset. This is the CPU, GPU, not that that matters very much. And then on the bottom, this is where we're going to insert our microSD memory card. And I think this is a memory chip, but it's not really necessary to know all of that stuff. So, and then there are 40 GPIO header pins that can be used to attach DAC hats. We're not going to get into that for this project, but Hi-Fi Berry, Just Boom, Allo, there are a bunch of different companies that make hats that are compatible with these things that can be quite nice as well if you want kind of an all-in-one network and analog audio out solution. So for this project, I just recommended that folks buy a little simple case. I've got this kind of clamshell looking case here. It's just two pieces that snap together. So I'm going to take the Raspberry Pi and kind of line it up with the slots in the case and press till it clicks and then pop the cover on top. And that's our Raspberry Pi device. All there is to it. Now that we've got this assembled, the next thing that we're going to want to do is prepare a micro SD card. Micro SD cards, really, really small. There's some pins for contacts on one side, and we don't need a micro SD card of any significant capacity. Even as low as 2 gigabytes will be adequate for a Raspberry Pi, or for a dietpi, the operating system we're going to be installing on this. This one's much larger than that. We're going to put dietpi as an operating system, and then as part of the boot up process, it's going to download and install Roon Bridge from Roon Labs so that we can use this as an endpoint, and I'll walk you through that configuration process. First step, though, is for me to insert this card into my laptop's card reader. So here we go. Now, the next thing that I recommend, it's not essential, but it's useful, is to go ahead and format that SD card. We don't know what might have been on there before, and I find it's just safer to format it. I recommend a utility from the SD Card Foundation called SD Card Formatter, unimaginatively. Whenever I format a card, I like to put a volume label of none just to make sure that I know that it's something that's freshly formatted. If I put other things on it, then I'll typically, it'll either get automatically a new volume label or I'll assign one. But if I see a card that's in my collection that just has none, then I know that it's not been used. You can't see this, but I'm getting prompted to put in a password to use the elevated privileges that are required for formatting this device. Kind of a nice feature. You do want to pay attention to the card. If you've got more than one card in your system, make sure that you're formatting the right one. I don't want anybody out there to reformat their thumb drive with their wedding photos of their entire music collection, so pay attention to that. In my case, I know for sure this is the right one. I can match the size and all the rest of that stuff. So just pay attention, be careful. I don't want you to lose your data. All right, SD card is now formatted. So as a next step, I'm going to, we're going to flash the dietpi image onto there. For that, we're going to use a tool called Etcher. Let me restart this because I've done this once before. Hang on a second. Insufficient sacrifice to the demo gods. All right, here we go. So Etcher is another free utility you can download. I like to use these settings, so everything turned off except for auto updates. In particular, we need to make sure that we leave auto unmount on success unchecked because we're going to need to make some modifications to this card before we put it in the Raspberry Pi. So for an image, I've already downloaded the dietpi image for this particular Raspberry Pi. You see it's an image that's about 1 GB in size. I'm going to double check and make sure that I've got the right media here. It's that 31.9 GB SD card I showed you. And we'll click flash. It's going to ask me again for a password, which you're not going to see. If you're doing this on Windows, be aware that some antivirus or anti-malware software, hang on a second, may block flashing of the card because we're modifying the boot block. We're not just copying that image file to the microSD card, we're writing it at a low level in a kind of a bit-for-bit way that will enable the Raspberry Pi to find the boot block and boot from it. And that process sometimes triggers antivirus software, so just something to be aware of. I'm doing this on a Mac, so I'm not going to see that problem here. This process usually goes pretty quickly, especially if you have a USB 3 card reader or if you've got a card reader that's internal to your computer that that can run. It's on the USB 3 or one of the faster buses in your computer. One thing that's nice about dietpi though is that it is a small, compact operating system, so it's much faster to flash typically than other operating system options that you could run on the Raspberry Pi. Alright, so that is almost finished. Great, that's done. Now that we've flashed the image, we're going to need to make some configuration changes. So let me clear this up here. So what I'm going to do, I know this may look a little bit scary, but I'm running a terminal window on my Mac. If I was on a Windows machine, I would be running a DOS prompt or a command prompt. It's a command line interface. We just have to do a little bit of command line work to get the image that we've put on this card configured so that it will boot up onto our Wi-Fi network. So on Mac, I'm going to cd2/volume/boot. And if you're on a Windows machine, you'd need to figure out what drive letter that microSD card shows up as. For example, it might be D:, or E:, or F:. You would type, for example, E:, in your DOS prompt, and that would drop your kind of DOS prompt into the top level of that microSD card. On a Mac, we're going to use this cd command change directory command to get to that location. And just to kind of give you an idea of what's there, I'm just going to take a look at all the .txt files that are there. If you are on a Windows machine, you type dir and then star.txt, you get similar kind of output. I want to draw your attention to this dietpi.txt file and this dietpi-wifi.txt file. We're going to be making some modifications to those so that when this Raspberry Pi boots this card for the first time, it shows up on our Wi-Fi network. In order to get it on our Wi-Fi network, we need to tell it what our Wi-Fi network's name is and what the password is, and there are some other parameters that we'll have to set as well. Now, we could edit these files by hand. Let's take a look at what's in these files. You can see there's a whole bunch of what we call key value pairs. There's a name and then a value that's set there. We could edit this file by hand, but as you can see, it's not very much fun to edit all those things, and you have to get everything just right or it won't boot up correctly. So I've written a script that will edit this file for us after asking us a few simple questions. The script is written in a language called Perl. On Windows, you'll have to install an application called Strawberry Perl to run the script. on Mac OS, Perl comes installed by default. So I'm just going to type Perl. Well, first we need to download that script. So that script is accessible from ws-e.com/dietpi-setup. You could download it in a browser if you wanted to, or both Windows and the Mac come with this utility called curl. So you can type this simple command here, curl-LO dietpi-setup. This is the file that we're going to save it as, and this is the address where we get it from. And that will go ahead and download that script for us. Now we can type Perl dietpi-setup, and we're just going to get answers to a few questions here. It says that it's going to modify the dietpi.txt. It's actually going to modify dietpi-wifi.txt as well if we have a Wi-Fi network. Let's give this thing a name. I'm going to call it Roon-RPI3A, since that's the kind of thing this is. You can come up with any name that you want. I would try to make it short, and only letters, numbers, and dashes are required. I'm going to say yes, that we do have a Wi-Fi network. In my case, my Wi-Fi network is for guests, audio files, and the password, of course, is Roon Rocks. And the script is then going to tell us what configuration parameters it modified. We can see here that it's installing application ID number 1 and 121. You don't need to worry about these numbers too much, but I'll just explain quickly that 5 is the ALSA utilities for Linux. It's something that provides us with some command line utilities for debugging sound card issues if we need them. It's just nice to have. 121, though, most importantly, is the Roon Bridge application that will allow our Raspberry Pi to show up on the network and be visible to our Roon core. You can see that we've got our hostname set here. Another important parameter is the time zone. I've written the script so that it tries to guess what your time zone is, so it should put a value in there that is appropriate to you. It's important to get the time zone right because the Wi-Fi radio frequencies and bands that are allowed in different countries tend to vary, and so the Wi-Fi system may not come up correctly and may not use the right frequency bands if this time zone is not set correctly. I believe that's the parameter that governs that. And then we've got our Wi-Fi password and SSID. I'm going to get out of this directory now and eject the card. If I didn't use this change directory command to get out of here, then I would get an error message from the operating system saying, hey, the device is busy, I'm not going to let you get out. I'm opening, you can't see it here, but I'm opening up Finder under Locations. I'm looking for boot, and I'm going to click the eject button. It's just like a triangle with a line under it. And that has cleanly ejected the card. It's important to do that because we want to make sure that the changes that we wrote to the card for that configuration have been flushed out to the card. So at this point, I'm going to remove the SD card from my card reader and put it in the Raspberry Pi. Again, we want to make sure this is installed in the right way. The pins, the gold pins here, need to face the green motherboard. So it kind of goes upside down. This is the Raspberry Pi held right side up. This is upside down. So we want those pins to face the Raspberry Pi. And we should see the label when we're holding the Raspberry Pi upside down. If it doesn't go in smoothly and easily, then you may have it turned the other way. Don't force it, just gently pull it back out and switch it around. So now we've completed the Raspberry Pi's assembly and put the card in. I'm going to get it's not necessary that you do this, but I'm going to get an HDMI cable and connect it so that we can watch what this thing does when it boots up. And I'm going to get a power supply. In this case, I'm just using a little iPad charger or iPod charger. It's just something that I had lying around the house, but it works okay for this particular device. So I'm going to plug it in, and let's switch over to a screen so we can see if it boots up. So if you had a display connected when you connect power, you should see those 4 raspberries at the top, and you should see some messages. Don't get hung up in details about what all those messages are saying. This first step, though, takes a while. This is dietpi working out how much space is available on the microSD card and then expanding the file system to use all of that space. So by default, dietpi assumes that you only have a 2 GB SD card, just so that you can use the smallest card available. But on first boot, the first thing it does is try to figure out how much space is available and expand the file system to use all of that space. After that, it's going to connect up to the network, and it's going to update itself. So just like any other operating system that you've installed, after you download the operating system image from the manufacturer or get it out of the whatever installation media you have, there's always going to be a bunch of updates that need to be installed afterwards. And this update process tends to take the longest part of getting this thing set up. Fortunately, there's nothing that we have to do. We just sit here and wait for it to finish. I will say that the Wi-Fi network in my loft is probably the weakest in my house. We have a 4-story house, and the loft and listening room area, which is where I am broadcasting this, is at the very top of that 4-story house, and all of our Wi-Fi signal is sort of beamed downwards so that we get good coverage for the rest of the house. Consequence of that is that the coverage is weakest up here. It's good enough to work with my Roon remotes so that I can control the audio system, but it's not great for this kind of bulk transfer type of work that we're doing here. I'm hoping this gives you an idea of kind of worst case how long this should take. If you've got a stronger Wi-Fi signal when you're setting up one of these Raspberry Pi 3As over Wi-Fi, it should go faster. So at this point, we are going to begin updating the other applications that are on the Raspberry Pi. If I can see, I've got my monitor across the room here, so it's a little tricky to see. Again, if you don't have a display connected to your Raspberry Pi when all this happens, you don't have to. You can just go have a coffee, have dinner. When you come back, if it's not available, then you can do some troubleshooting. In fact, while we're waiting, I'll walk you through some of the troubleshooting steps that I tend to do just to see what's going on if I'm curious, if it seems like it's taking longer than it ought to. So there's an application that you can install on your smartphone called Fing, F-I-N-G. It's a free application. It has ads. I've logged in so that I don't have to deal with the ads, and I'll show you what that looks like. Hang on a second. That's not the right window. There we go. Maybe. There we go. Yeah. So this is my my phone. I'm gonna go and launch Fing, and you always have to press this refresh button in order to get the latest information. So we'll go ahead and let this rescan my Wi-Fi network or my home network to tell me what devices are there. Now I've got a bunch of Raspberry Pis, but you probably don't have as many, or if you do, you can kind of recognize which ones are which. But I happen to know that this one here, this 8.29, that's the Raspberry Pi that we're looking for. With this application, I can do a quick ping test if I want to, which is kind of nice to verify that it's reachable. There are other utilities in here that you can kind of play with as well, but it's nice to just know that the thing is available and working. So it's a useful tool. If for some reason it doesn't seem like it's booting up, if you just want to make sure that it showed up on the network, this is a useful tool. I'll show you some other debugging tips that we can do that require you to know what that IP address is. So for future reference, in here we're going to use this .29 address if we need to log in. Ideally, you won't have to worry about this. The Raspberry Pi should just show up in Roon as an output that you can enable, but if for some reason it doesn't, this is a useful tool for troubleshooting. And when you're doing this DIY stuff, it's good to have troubleshooting tools. All right, let's go back and see if this thing has gotten closer to booting up. Hang on. There we go. All right. Looks like it's running through kind of its final stages of updates. Again, some of the advantages of doing this once you have the stuff set up, this is a very small, very low noise, very low power device that you can set on the floor behind your rack. You can set it in kind of an inconspicuous place. It just needs to be a USB cable's distance away from your DAC, so a meter or so away. I don't know if I would necessarily set it right on top of the DAC, but it's small enough that it can just slip behind You typically won't have to do anything with this once it gets powered on. It'll just kind of silently run in the background. There are no fans. There are no mechanical discs. There's no mechanical vibrations. It's a very, very quiet, very small device. It does require that you have a switch mode power supply someplace to run it. So if that kind of weirds you out, you could look at doing a 5-volt linear power supply. If that's quieter, you could look at running it off of batteries. I know that some people explore those routes. I've explored that a little bit. I haven't found any significant advantage to doing those things. I played around with using the iPower 5-volt power supply. I'm not sure if that made a significant difference or not. Maybe for a little while I thought maybe it did, but if it was a very, very tiny difference. If you do decide to use an aftermarket power supply, definitely make sure that it's a 5-volt power supply. I have destroyed at least one of these by connecting a 9-volt power supply. And so make sure that it's marked correctly. You want 5 volts, typically 2.5 or 3 amps is plenty of current. Don't do 15. It's easy to get. 15 is the wrong size. So do pay attention to the voltage rating and current rating for aftermarket power supply if you decide to go that route. The power supply that I'm using is 5 volts and then just 1 amp. That's enough to power this little device. But if you're connecting a DAC that is not self-powered, you may need more current for that USB port to operate. It might be a good idea anyway. So Mac manufacturer's recommendations, I think, for the Raspberry Pi 3A Plus are 5 volts and 2.5 amps. For the Raspberry Pi 4, it's 5 volts and 3 amps. So just kind of pay attention to those power ratings. But the 5-volt part is critical to get right. All right, looks like the Raspberry Pi is just finishing up installing our applications, ALSA and Roon Bridge. It's downloading those from kind of the internet. In the case of ALSA, it's downloading from Roon Labs directly, Roon Bridge. Roon Labs controls the distribution of their software, so they want any kind of third-party use of their software to get the code from them. So dietpi is doing that properly. And this is the last stage of this final boot. It's going to try to set the clock on the Raspberry Pi to make sure that it's accurate. On my network, it takes about 20 tries for this to work. I'm not really sure why, but it's about done. With any luck. There we go. And we can see the IP address there. It's that 8.29 that we were looking at earlier. So that's the address. We can see that it's come online as expected. So let's go into Roon now, and let's enable this output. So we're going to go to Settings, Audio, and you can see I have a bunch of things, but I'm looking for this Roon-RPI3 thing that we just built. It's got to be in here someplace. Oh, and I see that it's not, and do you want to know why? It's not there because we don't have a DAC connected, and Roon wants to see a DAC connected to this thing before it allow us to enable it. So fortunately, I just happen to have a DAC right here. It's just a little self-powered or battery-powered USB DAC. I connect USB cable here, connect USB cable here. Let's get out of this thing. Now, if I was kind of confused about why that wasn't working, I'll show you a little troubleshooting trick that we can do. So if I go back to my terminal window, I can SSH, which is a secure shell login, and this works on Windows as well as Mac. 1.29. Now, if I've logged into this before, SSH is going to try to protect me because it's confused that the security key for this device has changed. Don't worry about that too much. You probably won't run into that. I'm just going to clean my file up here, and we'll SSH in one more time. Accept the new host key, and then the password for this device is dietpi, all lowercase. We'll accept the GPL license, and we can see that we're logged in. We've got some nice information here. Tells us what our CPU temperature is. 48 degrees Celsius is a good healthy range for these devices. We've got some suggestions for command line tools that we can run, but we're going to run something that's not listed. It's part of the ALSA tools. It's a play-L. this will list the audio devices that we have connected. Now, before, our DAC wasn't showing up. If I had our DAC disconnected, or I can power it down, if I ran aplay-l again, it would say no sound cards found. If you see this, then you've got to make sure that your DAC is connected. You make sure that your DAC is powered on. Make sure that you've got a good USB cable that's connected properly. There are some DACs that are only compatible by default with USB audio class 1. The Raspberry Pi needs to see a USB audio class 2 device. I know Benchmark and some others that I've seen, I think it's Benchmark, have either dip switch settings, or there are settings in the menu of the DAC that let you choose the USB audio class. I think even my home theater pre-pro from Emotiva, I had to go into the menu settings and change it to use USB audio class 2. 1 was the default. So if your DAC isn't showing up, that could be the reason why as well. If I switch it back on and I run the same command, then we can see that the DAC is visible. If aplay-l doesn't show your DAC, Roon's not going to be able to see your DAC. So it's a useful troubleshooting tip to keep in mind. All right, let's go back to Roon and configure this guy again. So I'm going to go to Settings, Audio, and again, we're going to scroll down until we find that. There it is right there. You can't see my mouse pointer, I don't think, but I'm going to line it right up with that audio tab. It says RPA Roon-RPI3A and that 8.29 address, and so I know that's the right one. It's not enabled by default. New outputs aren't, so I'm going to click Enable, and then I'm going to go into Device Setup. So the first thing that you'll want to do, if you have a DAC that is Roon tested or Roon ready, it should show up in here, the manufacturer, and then you can choose which DAC you have. And the nice thing about that is that you'll get an icon that illustrates the DAC as part of the UI. It's a nice feature. You'll also sometimes get a PDF manual that you could open for your DAC that just shows up right in the Roon UI. And then you'll also get a set of configuration properties that Roon is tested and verified to be optimal for your DAC. So it's pretty nice if you have a DAC that's supported. Mine is an iFi DAC, and I can see there's not really anything that matches. So I'm not going to be able to take advantage of those things. So I'll just click out of that. I happen to know that this DAC does native DSD, so I'm going to choose native there. If your DAC does, but it's not native, you might end up using DOP, which is still fine. There's no big deal. It's no problem there. I know that this device is an MQA renderer only. This property seems to be rarely detected correctly, so you may have to change that if you care about MQA at all. For device volume, for volume control, I'm going to use fixed volume because this device has a volume control on it. If you're going to be using your device with a preamplifier or an amplifier or some kind of external volume, a fixed volume is probably what you want as well. In some cases, it's handy to use Roon to control the volume, so just kind of pay attention there. But generally speaking, if you're connecting this to your audio system, fixed volume is what you're going to want to use. I'm going to save this, and then I'm going to go back in here one more time to the advanced settings, and we'll take a look. So 384 kilohertz is right, 32 bits is the sample rate that this DAC likes to use. It detected the DSD capabilities correctly. One thing that I'm going to want to leave MQA core decoder enabled. I think that's a good idea, even if you do have an MQA DAC that supports full decoding. I think the only exception is the Meridian Explorer, which doesn't seem to work very well with the setting, but most DACs are going to work better if you happen to have MQA and you care about that, to leave this on. There's really no downside unless your DAC just doesn't support rendering that you'd want to have that on. So the last change that I'll make is to force the max volume at playback start. Some DACs by default are kind of come up with the volume at about 75% inside of the endpoint. And so if the volume seems like it's kind of soft, just go into this advanced setting and set force max volume, and you won't have that problem anymore. All right, let's get out of settings and take a look at what we have here. I'm going to choose this DAC. This is this Loft iFi DAC. I'm going to click the gear here because we've got a couple more configuration parameters that we can set. It was on here because I had it on from before, but I think by default volume leveling is turned off. I definitely recommend that you turn volume leveling on at the album level. That works extremely well for every case that I've discovered so far. I can go into a ton of detail about why this is important, but just trust me for now and turn it on. If you have loudspeakers in a room, you might want to use a target of 18 LUFS or one of these lower values. If you're using headphones, or if this is just for background music, I found that 14 left's the default as a target works really well. So now that we've got that on, another setting that if I know that I'm going to be using this thing for headphones, I've got some DSP presets here. But one of my headphones preset just turns this crossfeed DSP on, which is kind of a nice feature. If you don't see that, you can click Add Filter and find it there. There are also kind of cool features, like if you have a specific model of Audi's headphones, you can choose that there and apply an Audi's headphone specific contour curve. I don't, so I'm going to click out of there. And then finally, let's go find some music to play. This looks kind of nice. Well, I'll go back to this one. And we'll just click play to play a track. Now, if I had headphones plugged in, I would be able to hear what was going on. If you don't like the icon that showed up here, another kind of neat trick, you can edit this zone icon. If your DAC wasn't recommended or recognized, or Roon tested or Roon ready, you can choose kind of whatever's appropriate here. It's getting close to dinner time, so I might choose a knife and fork, but you could choose, for example, kitchen table. If you had this thing in a dining room, if this was your dining room music system, you can modify the icon there, and it just helps family members to be able to quickly identify which zone you have, especially if you've got a lot of zones in your house like I do. Let's take a look at the signal path. I'm going to click on this little star here. We can see that the source is a CD resolution file. Roon is converting that from 16 bits to 64-bit float because it's going to do all of its DSP and any kind of changes in using 64-bit math, which is the most accurate. First thing we're doing is volume leveling, so we're pulling the leveling down. This album's pretty hot. We're doing some crossfeed stereo to binaural DSP to make it sound nicer with headphones. Then we're doing a bit depth conversion again from 64-bit to what the DAC likes to see, which is 32 bits. This might be 24 bits or 16 bits, depending on what kind of DAC you have. And then we're sending it. We want to make sure that this is correct. We're sending this to our Roon-RPI3A output. That's the one that I named. If you chose a different name, that's what you'll see here. And then we're going to that iFi audio driver via the ALSA. Describes the technology that we're using there. So that is pretty much all that's involved. If I was doing this with a Raspberry Pi that had an Ethernet connection, I would go through the same process. The only difference is that I would say no to that question about Wi-Fi, and the Raspberry Pi would just boot up using a network connection, a wired network connection instead. There's some advantages to using a wired network connection. In some cases they can sound better. There are fewer drop packets typically. There's less noise in some cases. Certainly there's greater reliability. So I would encourage you to use a wired connection if at all you can. But if you can't, Wi-Fi is a pretty convenient solution. Or if you just need the portability and flexibility of doing this over a Wi-Fi connection. Anyway, so that's pretty much all that I had in mind to show you. I hope this has been helpful.